Hello, today we are covering 6.6 function operations. You guys will be able to add, subtract, multiply, and divide functions, and will be able to find the composite of two functions. So we start by adding and subtracting functions. So we have let f of x, that is how you read this, f of x equal 4x plus 7, and g of x equal 2 plus x. And then find the following. So it says f of x plus g of x. Now, sometimes it would be written this way. It's like they factored out the x term and put it on the outside. It really means the same thing. Okay? So when it says f of x plus g of x, that just means what f of x equals 4x plus 7. You plug in for it, and what g of x equals 2 plus x, you plug in for that as well, and then notice you just bring down that addition sign. From here we combine like terms, and we get 5x plus 9 as our solution. Now, sometimes you will be asked about domain and range of certain things. We have a linear function here. If we were to graph it, it would be something like this. So if you notice, the domain is how far the graph goes left to right. So this picture right here, that means it has all real numbers, or negative infinity to positive infinity. It's going to go on forever. A parabola also has x values that go left to right forever, so that's all real numbers. And any linear function also is that way. Now we can have functions that start at a specific spot, like this one, where this one, say it was on a coordinate over here, this was over 5, that would be x is greater than 5. So all real numbers with x greater than or equal to 5. It would keep continuing on in the x positive direction forever. So this one would just be all real numbers here. If we were asked the range, that's how far the graph goes up and down. Notice all linears have all real numbers. Then you would say all real numbers, or negative infinity to positive infinity, things like that. That'll come more into play in just a little bit. So then if we take f of x minus g of x, you just take your terms. I am going to put them in parentheses to start, like so. Notice you are not just going to simply subtract 2, but this is like multiplying by -1 here. So you have to distribute that through. Sometimes you say add the opposite. I like to call it that. Sometimes people say keep, change, but I don't really like that one as much. So I say add the opposites for each of the following terms. So I'll rewrite this. We end up getting that 4x plus 7 minus 2 minus x is our new rewritten version, because the signs of the second parenthesis both change. And then we go ahead and we combine like terms like we did before. So we end up getting 3x plus 5 as our solution. You can once again state the domain and range if asked. And then when you multiply and divide functions, this is our foiling idea. You are going to just say that x squared minus 9, that's the f of x term, times g of x. X plus 3 need to be multiplied, so we do our foiling. First, outers, inners last. So x squared times x is x cubed. X squared times 3 is plus 3x. Negative 9 times x is negative 9x. And negative 9 times 3 is negative 27. You can't combine any like terms here, so once we are done foiling on this one, we are actually done completely. And then we are asked to divide. So we take the division of f of x over g of x, like so. Now, this numerator can have some special things done with it. If you recall, we have something called a difference of squares, which is what we have now. So we can factor this out. So we have x minus 3 and x plus 3. Notice if you FOIL, this goes back to our original. That has to happen. And that is still over x plus 3. Now if you look, something in the numerator and in the denominator completely line up, so they can cancel each other out, leaving us with x minus 3 as our solution. Now if you are asked the domain on this problem, it is all real numbers because this is a linear. But there is a stipulation. If you were to plug -3 into this original equation, you would get a 0 in the denominator. You cannot divide something by 0. So it is all real numbers except where x equals -3. So x cannot equal -3. So that would be your domain of this problem. It does look like, since it's linear, it would be all reals, but we have that one stipulation if you plug in -3. All right. And then this next part is one of my favorite things to do in Algebra 2. It's called composing functions or compositions of functions, things like that. You'll notice that we have this weird like O type thing. It looks like we're saying fog and goff and foff, lots of weird stuff, right? It's not a multiplication symbol, and you're like, what about multiplying? Well, it is a composition of functions. That means you're going to be putting them together. So f of g of x can actually be written like this. These are interchangeable. They work the same way. It's almost more difficult to write out the steps. It's pretty easy to think through them. So you are going to plug the equation for g of x into the x part of the f of x equation. That's all we're doing. So if g of x equals x squared, you can say f of x squared. And then plug x squared in. So our solution is x squared minus 5. And that is what f of g of x is for these specific expressions. If you want to find f of g of -3, one way you can do that is just do what we did before, find f of g of x and then plug -3 in. That is perfectly logical. Totally fine. The way that I think is easier is go ahead and plug -3 into the g of x equation. So g of -3 will equal 9. And then whatever you find for that equation, you plug 9 into the f equation. So 9 minus 5 is 4. Really, it's the same thing, just two different ways to go about it. All right, and then part B, we have g of f of x. So we're just reversing these. Now we're putting the f equation, x minus 5, in for the g equation. So maybe it'd be easier, g of f of x. So now we have g of x minus 5. Go ahead and plug that in, and that will equal x minus 5 squared. You could FOIL that if you wanted. It depends on what the answer is asking for. And then f of 2. There's the two different ways you can do it. You can find f of x, like so, and then plug into maybe we'll want to say f of x, where x equals 2. Or you can find f of 2, where you just plug in 2 and go from there. We'll start with the first way. So f of f means we plug in the f equation into the f function where the x is, right? So it'll look like this. Then we go ahead, maybe it'd be easier if I don't skip a step, f of x minus 5, there we go. Then we go ahead and combine like terms, and then plug in the x information, we get -8. The way that I honestly think is easier is just plug in 2 to the f equation, so we get -3. And then you plug -3 in again to the f equation, and we get -8 as well. So either way we go about it, we both get the same answer. All right, that's all for today. Have a great afternoon.